So today I'd like to do a video on Geomatica Object Analyst. Recently I found some videos on YouTube that were using open source tools which are great. PCI has developed a commercial version of object-based image analysis. It's called Object Analyst. It's been available for about 1 year, a little bit less than 1 year, and it's a module that is available inside Focus. So what I'm going to do is actually use a very similar image that was used in the other video and show you how the process works within Geomatica Object Analyst. So the first thing I'm going to do is find the image, and I did a quick search on USGS to find the exact same image, and this is it here. It's in just close to Charlotte, North Carolina, just north of Charlotte, North Carolina, and this is NAIP GeoTIFF data, and it was collected in May 2016. And so I've downloaded that data, and I'm going to start working with this imagery. So I can simply drag and drop the image over here to Focus, and if I go to the Files tab, you can see that I have 4 channels. So I'm just going to rename these so I don't get confused down the road. So this is my red channel, green channel, blue, and then this is NIR. And let me just do a false color composite, so NIR, green, blue. There we go. So there's our image. And what I'm going to do is I'm just going to cut out a piece. So I'm going to work down in this area. I can simply use the clipping tool. I'm going to clip all the bands. I'm going to select an area. It's got a nice mix of water and bare soil and grass and all sorts of complicated things to work with. And I'll just call this my subset. And I'll go ahead and clip it. Close that out. Open up the image. Just the subset. And I can just change my color mapping again. So one of the things that we're going to use quite a bit in this data set, because we have infrared, we can calculate a vegetation index, and that's going to help us to separate some of the classes. So let's do that right now. So we can do the vegetation index using the algorithm Librarian. We can pull up one of these algorithms. There's over 550 algorithms available within Geomatica. This one happens to be an algorithm that deals with creating vegetation indices. So I can specify my red channel and my infrared, which is all I need for the NDVI vegetation index. Going to export that to the same file. It's going to create a new channel, and I'm going to specify here that I want to use NDVI. So you can see that we have lots of other vegetation indices, but for now I will specify NDVI, and I'll run that. Close that out. And you can see that this is my vegetation index, so let me just name it so I can find it more easily. And if I view that as a grayscale, you can see that this is logical. Our water is dark, our trees are bright, and if I look at the numeric values, everything makes sense. So these are my low values, and my higher values are the trees. Okay, so let's start with the segmentation of the data. Segmentation is actually going to give us some nice objects. So the algorithm essentially looks for pixels that are similar to each other and keeps growing the object until it reaches a discontinuity in terms of the similarity of the pixels, at which point it creates a new object and then follows that object and gives us individual objects that we can use for our classification. So I'm going to pull up the Object Analyst tool. So under Analysis, Object Analyst, first thing I'll do is I'll choose Segmentation. Now there's a few parameters I need to provide. So I'll select the image that I want to use for my segmentation. So I'll use the subset of the NAIP data. I'll choose all the bands with the imagery. And the next thing I'll do is I'll select the scale factor. I'm going to leave it at 25. The shape and compactness is kind of neutral, so it's going to try to grow the objects for different types of situations, so I'm going to leave those by default. And what I'll do is I'll just name this segmentation 25. give it a little attribute name, and I'm going to run that. So there's our segmentation. As you can see, that was pretty quick. It took about a minute or so to segment this data set. And I'm just going to open it up. So we have a separate vector file now. And if I explore the attributes, I can basically explore some of this data right now. So I have the square meters for each polygon, the perimeter, and that's about it at this point. But you can see that it did quite a good job at following some of the objects. If I zoom in at 1-to-1 here for some of these dwellings. So we've got the houses kind of nicely separated. We've got some polygons over here that represent the open areas, the forest, the different types of forest, and water bodies are quite nice. You can see the water bodies, or they follow the coastline very, very nicely. And that did a pretty good job. So one really important thing that I want to do now that I have my image segmented is I want to provide the information that's available inside the image for every single one of these polygons. I can use that for my classification. I can use it to build rules. I can use it to build conditions. There's a lot of information in the image itself that I can associate for every single one of these objects. So what I'll do is I'll pull up Object Analyst once again, and I'll just go down to the next step, which is feature extraction. And in this case, I'm going to select all the bands, so the red, and I'll just give these a name so they show up nice in my table. So here you can type in the actual column heading that you want to use in the table when it's going to create the feature class information. And I'll select OK. In addition to the values for each one of those bands plus the NDVI, I can also get geometrical properties. So I can look at the compactness, the circularity, the elongation, and the rectangularity of all of those objects. So by default, it's recommended to keep only the mean. You can also choose the standard deviation to look at outliers and this kind of information. So I'm going to go ahead and run this step. It should be pretty quick. So that step is done. And if I open up my polygons once again, you can see now that I have a lot of really nice information that I can use for my classification. So for example, if I pick a water polygon over here, I have the mean value for the red band, the green band, the blue band. I have the near infrared mean value and also the NDVI. So you can see the NDVI is quite low. And I have some information about how circular the object is, how compact, what's its elongation, and it's rectangular. So if I compare that to a road feature, you can see that the elongation is quite a bit higher because it's a long feature. And so these are the types of things that I can use to improve my classification, but also build rules and build conditions to solve problems down the road when I'm working with this data set. So now that we have a lot of information about each polygon, such as the mean values for each band, the NDVI value, the elongation, all those geometrical properties, we need to tell the software what each class is in general. So what I'll do is I'll create the same classes as was used in the other example, and I'll just pull down the training sites editing, and you can see that it gives me this nice dialog, and I'm going to add 6 classes. So 1, 2, 3, 4, 5, 6. First class is bear. Second class water. Third class open. So this is like grass, trees, impervious, and then we have this problem with this data set, which is shadows. Because it was taken in May and there's a lot of foliage, we have quite a few shadows to contend with. So I'm just going to use the same color scheme as the other video that I saw, and so I'll choose bear, water, open, trees will be green, impervious red, and shadows will be purple. Okay, so the process of training is quite simple. We can essentially pick a class. So I'm just going to go with water because that's quite an easy class. And I'll use my select tool. And I can just select a number of polygons that represent water and assign them. So you can see that it's keeping count of how many polygons I have chosen to be water at this point. I'm going to assign those. Now it is important to have good distribution of these polygons and also to ensure that they're spectrally similar in the different bands. So normally something like 10 to 15 polygons per class is sufficient. So for bear, this is essentially, there's an industrial site here, and we can see that there's quite a few sort of sandy areas or bare areas. So I'm going to select these and assign them to bare. And I do have some other areas that are bare. So for example, this baseball pitch, those are similar, those are sandy. There's some other bare areas up here, some of these sand traps inside the golf course. Assign those. Open is our grassy areas, so I'm going to select some of these fields from the baseball diamond. A lot of these open areas here in the residential areas are quite similar. I'm just using shift click and multi-selecting a bunch of polygons all at once and then assigning them. And for trees, we have lots to choose from. This is quite a treed area, so I can actually click and drag a large area here. You can see that that's grabbed quite a few polygons here. So I've got 32 just in that one. This is quite a heterogeneous area, so it's normal that the segmentation gave us many objects. And if I go to this area, just want to make sure I get different types of trees. Now one of the problems that we're going to have with this data set is we have trees and we have some of these dwellings inside, so we're going to get shadows. So we'll have to handle those very carefully. So for impervious, I'm going to select some. I'm actually going to create a few classes for impervious. We have sort of darker impervious features because the roof, for example, the roofs here are the sun is casting a shadow on this side on the west side of the roof. So I'm going to select a couple of different classes for those. I'm also going to select some classes for roads. The roads are quite similar to these roofs, so that might be okay. But then I've also got some white buildings that I need to be mindful of. So for example, over here there's a white building here. So for impervious, I'm actually going to create a few other classes. I'm just going to merge them later on. So I'll call this impervious 2 and impervious 3. And I can use the same color. That way things look similar as I'm working. Okay, so this one, I'm going to choose some of these darker polygons that are impervious. So for example, these sides of the roofs here that are darker. I'm being careful not to pick ones that are too similar to the shadows because that's going to probably cause confusion. If I had an elevation layer, I could do a lot, but I don't have an elevation layer for this data set, so it limits what I can do. Okay, now I'll pick some road features. So these are the sort of the lighter blue. And the other thing I'll be careful to do here is to try to select similar features, so long linear. That's probably going to help the algorithm. So if I make a mistake, it's not a big deal. I can assign and then unassign, so just kind of switch them on and off. Let's see if I can find some more nice roads here. So I'm going to have some problems here because the road is covered by shadow. So unless I sort of manually fix that, there's probably nothing I can do inside the data set with automation to automatically get it. Okay, and this one's going to be my white buildings, so I'm going to pick some of these white features. Okay, and then our difficult class is going to be our shadows. So let's pick some different types of shadows. We know we're going to get some shadows in the tree, so basically what's happening here is we have dwellings inside here. You can see there's a house here, but it's difficult to see it because we have this big shadow that's cast by the tall trees. We also have shadows along the edge of the forest here. We even got some shadows in the water, all along the in this open field here. This should be open, but it's being classified as, or it will be classified as shadow if we pick it up, and then we can reclassify it later, so we can fix it. So that looks pretty good. So what I haven't done is I haven't collected any accuracy polygons, so we do recommend that you do that so you can determine what the confusion is in terms of your different classes. You could do some accuracy assessment, but for this example I'm just going to go ahead and do the classification directly. So I can close this out and move on to the next step, which is classification. So the classification algorithm that's built into Object Analyst is based on SVM. So we have some research scientists on staff who have looked extensively at different algorithms such as random forest and SVM and neural networks, and through a lot of testing and quite a bit of research in the literature, ultimately we chose support vector machine to be the best machine learning algorithm to allow users to get the best possible results from the data. So assuming good distribution of training classes and good preparation of your data, this algorithm will give you good results. So we do have the choice to do unsupervised, but we're going to do the supervised, and we're going to use our training. So this is basically a field. If I open up my polygons once again, my objects, you can see that now there's a training class. So this is the new column that was added to the data, and as I was selecting those polygons, essentially the software was providing those values in the table. And now what we're going to do is we're going to leverage these training sites to run the SVM algorithm. So I'm actually going to call this child class. And the reason I'm going to do that is because I'm going to do a segmentation at a larger scale factor and build in multi-resolution, multi-segmentation rules as we work our way through this data set. So let me go ahead and run the classification. You can see the results are up on the screen already, and just to sort of see things a little bit better, I'll turn off my training polygons so you can see the actual classes now. And so we can turn these classes on and off sort of one by one and sort of inspect where the problem areas are. So let's look at water, number 1. So our water seems to be doing pretty good, but it looks like we got some confusion in some of these residential areas. Some of those dark polygons got confused with water. So trees looks like it picked up pretty good. Got some nice classification of the trees. Our open class, this is our grass. And then impervious, so I'll turn them all on. And then our bare class. So these are picked up our nice area down here quite well. Some of our areas in our baseball diamonds, some of these sand bunkers on all the different golf links over here. So that's our initial stab, and if we turn everything back on again, that's our result. Now, clearly we have some problems. So if I zoom into the forested area up here, and I'll just turn this off for now, and there's one particular problem which we're going to have quite a bit with this data set, which is shadows. So if I turn this on here, you can see the shadows inside the tree areas are quite predominant. And really all this is just we have some taller trees, and then we have maybe a little bit of a gap between trees, and that's casting a big shadow. So we actually want to probably reclassify that to trees. In residential areas, we're going to have a similar problem. So you can see here that in this residential area, this is probably actually open grass between the trees, but it's getting classified as shadow. So we've picked up the shadow class and we can fix that. So our approach to solve some of these problems is to produce a segmentation at a larger scale, identify homogeneous areas like residential areas, forested areas, water areas, etc. And then what we're going to do is we're going to build rules and conditions to improve those classification results. So let's go ahead and do that now. So I'm going to turn off the 25 scale segmentation. I'll pull up Object Analyst once again. I'll select the segmentation step, use the same information from the bands and the NDVI. And this time I'm going to bump the scale up all the way to 150. So this isn't a number per se in terms of meters or feet or anything like that. It's just relative to the size of the data and the size of object that can be generated. So generally, the closer you are to kind of 0, the smaller the object, and the upper limit is somewhere in the neighborhood of 500. So I've played with this data set, and what I found is that for the purposes of what I'm trying to do here, which is to create sort of continuous zones where I can classify or reclassify problem areas with the shadows, 150 seems to be a really good a size. So I'm going to write that out to the same location. And you can see that I've got much larger objects now, and these objects are following some of these big areas that I want to classify or group together. So you can see if I click here, I've got kind of neighborhoods, and I can actually just manually select all of these areas and create my new classes. So let me do that right now. So I'll go through the same process. I'll run Object Analyst. I'll create training sites. So I'm going to switch this from the 25 to the 150. And I'm going to bring up the panel. Now you notice we don't have any training sites yet because this is a new segmentation. Now I'm going to create some kind of temporary classes that I plan on using for my fixing of problem areas. So I'm going to call this one trees. That's going to be our large tree areas. One called water, so we have some nice big water areas. I'm going to create a new class which is residential, because I'd like to handle residential areas differently than treed areas. I'm going to create my bear class. There's maybe some shadows I need to fix in the bear class areas. And I'll just create some other classes just in case. Okay, so this data set is small enough that I could actually run this all at once. Or I could select all of the polygons all at once. So let me just do that for a few minutes here. I'm not going to talk through this step, but I'll keep recording. Essentially what I'm doing is I'm selecting all of the areas that I want to use as the parent class to make decisions for the child polygons underneath. Okay, so I'm happy with that. I'm going to run the classification now. Can use a training field, and I'm going to call this parent class. So let's have a look at those results. The big residential areas. Now this layer doesn't have to be super accurate. What I'm really trying to do is I'm trying to create these big polygons that I can use to build rules down the road. So it's not super critical that everything is 100% accurate here. Here's all my treat areas. So you can see that the areas where there are trees, but not too many homes are the ones that are selected. There's a few exceptions there, but that's what's going on. Okay, so based on that, now I have what I need to start to join these two segmentations into one file. And then what I'm going to do is start to reclassify some of these problem areas. So the current classification has some problems related to shadows. These particular areas here, if I zoom in a little bit closer, you can see these are basically just trees and houses casting shadows on open areas. So these are actually grass, but they're being classified as shadows at the moment. So what I want to do is I want to use my parent class, which has residential areas kind of nicely demarcated. So if I turn on my residential area, you can see I've got these nice big polygons that represent areas where there's residential. And what I want to do is I want to take those shadows and I want to reclassify them to open. So I'm going to build a condition to do that. So I'm going to pull up Object Analyst once again. I'm going to use the rule-based classification. So the conditions have to meet two criteria. So the first thing is that the child class should be equal to shadows. I'm going to add that. Child class equal to shadows. Add. And parent class should be equal to residential. Okay. So that's going to create that new class in my new column, and it's going to only pick the shadow polygons that intersect with the residential areas and reclassify them to open. So let's run that. And there you can see that all of those polygons that are showing up in this color right now are being reclassified as open. So that makes a lot more sense. So let me turn off the residential, and I'll turn off the shadows, and I'll just make this the same color so it makes sense. So now we have those open areas and these open areas as well. So you can see that our classification is starting to take shape. So our open areas are now correctly classified. The shadow areas have been recovered. So that's just one technique that can be used. We can do the same thing for the shadows in the tree areas. We can do the same thing with water. So we can use the same principle to fix all of the different problem areas. Okay, so here we have almost the final result. This is once we've done all of our parent and child reclassification. We've done a little bit of cleanup. You can see that it's looking pretty good. We still have all the individual objects and a lot of detail in this data set. So we have our impervious, our trees, our open. It's doing a pretty good job at catching all of these different small areas. You can see even these docks going off into the water, even boats that are in the water, and quite a bit of detail there. So pretty happy with this result. Now the last step that we want to do is we actually want to basically just merge these polygons all into big continuous polygons where we can. So the way that we do that is we basically go back to Object Analyst, and there's kind of two different methods. One is interactive and one is automatic. So we can do the automatic dissolve, and essentially what that's going to do is it's going to take every single polygon that touches another polygon that's classified the same. So I can choose the classification here. So my final classification is reclass, and I can output that to a new file and just call it merged. So I'm just going to I've already run this earlier, so I'll just call it number 2. And I'll just go ahead and merge it. So I won't run that right now, but essentially what that's going to do is it's going to merge all of these into single polygons. Now another nice thing that you could do is you can actually interactively dissolve the polygons to each other. Now I don't obviously recommend that you do this to this entire data set because it's quite big, but it could be a nice way to fix kind of small areas. We also have the vector editing tool, so at any point if you want to sort of move things around or better delineate an area, then you can always use the vector editing tools to change the polygons for the different objects. So for example, if I go into this water area, you can see that this is composed of all individual polygons. So I'm going to pick the joined, and I'm going to choose a polygon, and what I'll do is I'll just go merge polygon, and you can see that when I'm on a polygon that's the same class that's adjacent to this polygon, it's just going to join them together. So I can keep going, and nice thing is you can actually maybe fix up these problem polygons that are just on the edge. So let's say that that particular polygon there was classified as impervious, and that probably doesn't make sense. That's probably water. So we can change that to water. So we could just kind of keep growing, but you can see that you can use this tool to fix kind of small little problem areas. Okay, so I've done the automatic dissolve, and I've also fixed up a few problem areas. For example, there were some kind of shadows that were lingering in the water over here, so I fixed those up. The process for fixing is both kind of vector editing, so I can pull up a specific vector and I can reshape it if I want. Use the reshape tool, this kind of thing. The other thing you could do is you can just simply pull up a polygon. So for example, if I have a problem area, let me just pick somewhere where I think is not right. Right, so this particular field here, now because I'm not using as many classes as this data contains, I have a polygon here that's classified as forest, but that's not forest, that's actually mostly an agricultural field. But let me just reclassify it as open, so I can open up the attribute table, go to that particular record and just call it open, and that reclassifies it. So you could do that for kind of little touch-ups in the classification as you're working your way through the data set. So hopefully that gives you a good idea of Object Analyst and the type of result that you can achieve. As you can see, the tool has a lot of flexibility. It's great for working with this difficult data set. I was able to solve some of the challenges related to shadows, and quite a bit of flexibility in terms of reshaping or reclassifying, and just a great tool overall. Hope you enjoyed the video.